Hello guys, my name is Engineer Alide. We want to solve question on magnetism, but before then, let me quickly explain something. Now, a magnet is an object or material that produces magnetic field. A magnet has two poles, which is north and south pole. Now, the strength of a magnet or the magnetic effect is most strongest at the north and south pole. That is to say that if you continue to cut a magnet into pieces, you keep having two poles, which is north and south pole. Now, a magnet is a single bar, is a solid bar magnet. As the word, it can be made of steel, iron, nickel, cobalt. It can be made of steel, iron, nickel, cobalt, and even made of what? All these ones that we are talking about now. Now, don't forget importantly that when a magnet is freely suspended, it comes to rest at the north and south pole, which is the magnetic field of the earth. Now, don't also forget that a magnet can repel itself if the poles are the same, but can attract if the poles are unlike. That means like pole repel while unlike pole attract. A magnet is can what we call magnetism. When you want to study the properties of what? Of magnet, the ability of a magnet to either repel or attract it like, or to repel it like, or repel its what? Another poles that are the same, or attract unlike pole, is what we call a what? A magnet. Now, it's what we call what? Magnetism. So magnetism, in other words, is what? The ability of a magnet to what? To either repel a like and or attract unlike. That's what I mean by that. Now, let's say the part of a magnet in which magnetic effect is the strongest are called pole. Neutral point is a point where the magnetic flux is what? Is zero. Or magnetic flux density is zero. So which of the following statement about magnet is correct? A freely suspended magnet points in the east-west direction. No. Brass is a magnetic material. No. Brass is not a magnetic material. You can say that steel is a magnetic material, although steel is an alloy of carbon and iron. Like pole attract. No. Permanent magnets are made of steel. Yes, correct. Don't forget, there are two types of magnet. We have the natural and the artificial. The natural ones occur naturally in nature, but artificial ones can be achieved by doping. Either you dope them with iron, cobalt, or what? Nickel. Now, these are what achieved when a temporary what artificial magnet is achieved. How do you know them? Example is iron. And iron, that means they are easily magnetized, easily demagnetized, and what? They don't retain magnetism for a long period of time. But when you talk about what permanent magnet like steel, which is a combination of carbon and iron, they are not easily magnetized, not easily demagnetized, and they can retain their magnetism for a long period of time. Now, I think this permanent magnet is the best answer because E says unlike pole repel. No. Unlike pole attract. Now, this one says which of the following is true about magnetism? Iron field cling mainly around the ends of the magnet. Yes, that one is correct. A freely suspended magnet comes to rest in the geographical what? North south pole. No, it comes to rest in the what? In the magnetic meridian north and south pole. That means what? If you have a what? The earth like this, written like this, drawn like this. Let me draw the earth like this. Now, if you draw it, you have something like this now. For instance, let me have something like this. Okay. Now, let's say we draw the what? A line like this representing what? The magnetic meridian north and south. Then you have your north pole, the bar magnet rather, this one is south, or let's say north. Why here will not be what? Magnetic what? Meridian what? North. Magnetic meridian south. Why this other place we called what? The magnetic what? Meridian what? North. So this is a bar magnet. So the bar magnet will come to rest at what? At the magnetic meridian north and south. This one is what we call the geographical meridian. This is what we call geographical what? Meridian north. Why this one is called what? This line is called what? The geographical what? This end, geographical meridian south. So that means you cannot tell me that a bar magnet, which is this, come to rest at what? At what? Geographical meridian north and south. No. So that is, this answer is wrong. A light poles what? Repair. Right? Light poles attract. Wrong. Light pole is what? Repair. Lodestone is a non-magnetic material. No. A lodestone is an example of a natural magnet, which means that it's an oxide of iron and it's a magnetic oxide. So it's wrong. Then the answer is what? A. So I will go with A now. A is the answer. They say, which of these following is not a property of a bar magnet? A bar magnet has what? Two poles. Yes. It exists as a dipole. It is made of soft iron. No. Steel. Yes. It can be made. It can be made. No, it is made. It is categorical statement. So then we cannot go with this. So let's say the poles are made of equal strength. Yes. The north and south pole are what? So if you have a bar magnet, the strength of this pole here and the strength here is the same. Then they say if it's really suspended, its end will point towards the earth magnetic pole. Yes, this is earth magnetic pole. This is what the earth magnetic north pole, and here can be called the earth magnetic south pole. So you can call it what? The earth magnetic pole. Yes, it will form towards the earth magnetic pole. So that one, the answer to that question is what? Is B, that is wrong. According to according to the molecular theory of magnetism. Now, what it is explaining on that molecular theory of magnet is that when a particular with the smallest magnet is what? Molecular magnet, and they reside in the magnetic domain. That means where they stay, the housing of a molecular magnet is what? Magnetic what? Domain. Don't forget the smaller magnets. The smallest magnet is what? Molecular magnet. Now, these molecular magnets, when they are properly magnetized, they what? They tend to align themselves in one direction. When they are properly magnetized, they align themselves in one direction, meaning that they point in one direction along the length of the magnet. So, and how do you know that they are magnetized? That's when they do that. But whenever they are demagnetized, what happens? They move randomly. So let me show you something here. That means if you have a molecular magnet like this, and what we are seeing that means inside this one, let's say they will point, even when they point in one direction like this along the length of the magnet, it means that what? They are already magnetized. But if they now point in either random direction, it means they are they are already demagnetized. That's what we are saying. They point in that manner, it means they are already demagnetized. Let me use a clearer marker. It means they are already demagnetized like this. You see them like this. So where the effect of one cancel out the other. So in this manner, they are already magnetized. But when they are when they are aligned, also you see form close ring, no, at each point at its end, pointing in what? In the same direction. That means all the molecular magnet at its end, only the end pointing in the same direction. No, they said was all molecular magnets are in straight line along the length. Yes, correct. Along the length. This one say are in straight line at right angle to the length. No. So I will go with option B. Then don't forget, when they point in one direction, when they have attained saturation, their magnetization is at its maximum. Don't forget. Take note of that. Magnet saturated occur. Magnet saturated or saturation occur. This will be saturation occur if what the magnet is at its maximum magnetization. Yes, that is the answer. A freely suspended magnet come to what? Rest with its axis pointing approximately what? North and south. So that is the total answer for chapter 1 and number 1 to 7. Don't forget to note that. Note that the magnet has two poles, north and south pole. When they are really suspended, they come to rest approximately at what? Or they come to rest at the magnetic meridian north and south. And when the magnet is suspended, it came to rest at the magnetic earth what poles, the earth magnetic pole. And they have two types of magnet. We have the natural and the artificial. The natural is lodestone, or what we call the magnetite or the oxide of iron. The artificial can either be permanent or temporary. When it's doped with to the material to make it a permanent one. How do you notice that it's not easily magnetized, not easily magnetized, and retain magnetism for a long time. But iron, which is temporary one, they easily magnetize, easily demagnetize, and cannot retain magnetism for a long period of time. All these things are very important. Don't forget that the ends of the magnet always have the highest strength of the magnet. The strength of the magnet concentrates at the ends of the magnet. So when you place an iron filling, it tends to click at the ends of the magnet. Then a magnet is when it's temporarily or permanent, when it's in an artificial mode. How do you know what are the examples of artificial magnet? Example were U2 magnet, horseshoe magnet, bar magnet, circular magnet, cylindrical magnet. These are examples of an artificial magnet. Thank you very much. God bless you. I hope you subscribe so that you can get more of our video. This month of April is month of question and answer. Thank you.